Today we will be talking about the nomenclature and terminology in an ECG. Now, I would like to start my lecture with this quote that if you don't know the ABC of an ECG, it's completely okay. Just remember that there are PQRST and sometimes an unknown U. I'm very sorry for that awful PJ and a frown on your face, but if it made you smile, then let's start. Now, let's start with some common terminology or common terms that are often used in an ECG. Now, our first common term, it is called a segment. Now, what is a segment? If you are already if you have already read about ECGs, you might be already familiar with the term, but people over here who are from scratch, it's for you. Now, sometimes when you read about an ECG, you might have come across the term PR segment or an ST segment, which is very famous when you learn about myocardial infarctions or heart attacks. Then basically a segment is an isoelectric line or a straight line that connects two waves. Now, speaking about that, this brings us to our next definition, a wave. A wave is a dome shaped, curved, or sometimes a spike that shows presence of current in a heart tissue. What does it mean? If you look into the diagrams over here, you can see a pattern in which there are some alphabets PQRST. Now, what is a segment over here? Now, by definition, it is a straight line that joins two waves. The letter P that is denoted over here, it refers to a wave that is being formed over here, and we call this wave a P wave. And over here that we see a spike, it's also called a Q wave. Some people might contraindicate over here that this might not be looking like a proper wave, but they are in an ECG, they are considered to be wave. Now the differences in the pattern of a P wave and Q wave is that a P wave has more privilege with time or is given more time, whereas Q has a very short interval of time. That's why the P, it's more like a dome, it's more like a wave, and the Q, it's more like a spike. And the line that joins these two waves is called a segment. So this is a wave, and the line that joins these two is a segment. Now, if you understood that well, the same, this is an R wave, this is an S wave. A combination of a wave and a segment is called an interval. It's not necessary, it has always has to be a wave and a segment. Sometime it can be wave plus wave. It's just a combination of more than one of these factors. We call it an interval, such as the PR interval or the PT interval. Now, if you understood this well, let's go a bit more into a detailed lecture about waves. The following diagram over here, it's a simple circuit of how an ECG machine works. The tissue that we see over here is a cardiac tissue, or you just imagine it's a cardiac living tissue. The two following over here that you're seeing plus and minus, these are the electrodes, and these electrodes are connected to a device that measures the presence of current in a circuit. If this circuit is complete and if this living tissue has some movement of electrons, then there will be a deflection in this galvanometer. And this deflection of a galvanometer, if you put a red ink on the pointer and you run a roll paper, you will see a pattern that is being formed. And this is how basically an ECG machine works. Now, why in an ECG paper the wave, sometimes you see the wave going up or sometimes the wave goes down. Now, it's not necessary to learn in very deep detail, just know this basic rules. Now, suppose I have an electrode. If the deflection moves toward the negative electrode, you will get a negative deflection by the galvanometer. That means if the electron in the cardiac tissue moves, these are electrons in the cardiac tissue, they move towards this direction, towards the negative electrode, you get a negative deflection. And if the vice versa happens, that is, if the electron moves towards the positive electrode now, then we will get a positive deflection. As simple as that. Now, this phenomena, I'm sorry, I should have mentioned it. These are called positive vectors or depolarization vectors. When a depolarization vector, when a depolarization vector moves away from the positive electrode, we get a negative deflection in a galvanometer reading. And if a positive depolarization vector move towards the positive electrode, then the galvanometer shows a positive deflection. Now let's see what happens in repolarization. Consider repolarization as a negative vector. If the negative vector moves towards the negative electrode, if the negative deflection moves towards the negative electrode, we get a positive deflection in an ECG paper. And if the repolarization vector moves towards the positive electrode, if the repolarization vector moves towards the positive electrode, then we get a negative deflection. You can remember this as a simple trick, that if plus into plus will of course give you plus, whereas plus into minus or minus into plus will give you minus, whereas minus into minus will give you plus. So again, saying, just remember it quick in a mathematical formula, as we learned in multiplication, that any negative number into a positive number gives a negative, gives a negative. The same applies over here. Any negative moving towards positive or any negative into a positive will give you a negative, and the opposite sign, positive into positive, gives a positive. Negative into negative will give also a positive. So you can just remember this as quick. So this is basically how a wave that you see, it either moves up or it has to go down. Going further, sometimes you won't see any deflection or you won't see a wave. You will see an isoelectric line, which are referred as segments. Now, these isoelectric lines can be present in resting membrane potential. When there is no flow of electron, there will be baseline, or it can be seen during complete depolarization or complete repolarization. That means there was an excitation in the cardiomyocyte, and this change has now completely over that cardiac tissue, that it's a common charge. So initially you will see a wave of excitation and it will come down as an isoelectric line. So in such cases, the galvanometer does not make any deflection and we get a straight line. Or sometimes when we place the electrode in an incorrect manner, we might also sometimes get an isoelectric line. It's not necessary that when an electrode is always placed in perpendicular way or in at 90 degrees, we always get an isoelectric. Like sometime in some of the leads, you might get a biphasic line, that is a wave that goes up and a wave that comes down. Now, what's the mechanism of formation of such waves? Because sometimes these isoelectric line and biphasic line can be simultaneously same on an ECG paper. Now, what this means is that if you have an electrode like this and the vector is moving in this direction, or you can say the electrode is placed perpendicular to the cardiac tissue, then you will get such a wave. Now this happens, the initial part A is because you divide this into two parts. You divide this into two parts, one component like this, the other component like this. Now initially the part A, the wave is moving towards the electrode. That's why you see a positive deflection. And then you move away from the electrode, you get a negative deflection. Now considering this wave was a depolarization. So if a positive deflection, if a positive vector or a depolarization vector is moving towards the electrode and then going away from the electrode, as the electrode is placed in a perpendicular or at middle of the cardiac tissue, you might sometime get a biphasic wave.
तुम दोनों में से जूता अच्छी तरह पॉलिश करना किसको आता है?
मुझे नहीं आता, इसको बहुत अच्छी तरह आता है, मास्टर है मास्टर।
तेरा नाम क्या है?
बांडिया।
क्या? डांडिया?
बांडिया बांडिया।
अच्छा डांडिया। डांडिया देख,
हाँ?
पहले तू जूता पॉलिश करना सीख। नटवर, इस घर के सारे जूते लाके इसको दे दो।
चल मोची।
इतने सारे जूते अगर मैं फुटपाथ पे पॉलिश करता तो इतनी कमाई होती कि एक हफ्ते के अंदर मैं एक नाव खरीद लेता।
ये लो, ये थोड़े से और पुराने जूते हैं, इन पर हाथ साफ करके अच्छे से पॉलिश करना सीखो, और नए भी देंगे। और कुछ जूते पैरों के साथ चलकर बाहर गए हैं, जैसे वापस आ जाएंगे वो भी देंगे।
अरे गाजपाटा, तू क्या कलेक्टर बनने वाला जो साला बैठा बैठा पढ़ाई करे? कुछ काम कर।
नहीं नहीं नहीं, ऐसा नहीं चलेगा। जिसको जो काम दिया उसको खुद ही करना पड़ेगा, और वो भी दिए हुए वक्त पर, नहीं तो कुत्ते के पट्टे के साथ यहाँ पर पिटाई होती है।
अच्छा, ये मजाक। अब तो वक्त के अंदर काम करके दिखाता हूँ।
फटाफट ये काम खत्म करोगे तो तुरंत दूसरा काम दूंगा।
मैं कोई बोतल से निकला हुआ भूत हूँ कि एक के बाद एक काम देते ही जा रहे हो?
अच्छा ये बताओ, तुम दोनों में से अच्छी तरह कपड़े धोना किसको आता है?
एक और काम, ये तो मैं हरगिज नहीं करूंगा। हाँ। मैं बहुत अच्छी तरीके से कपड़े धोता हूँ, इसको बिल्कुल नहीं आता। मैं इसको बिल्कुल सिखा दूंगा।
नहीं नहीं, कपड़े महंगे हैं, जो नहीं जानता वो धोएगा तो कपड़े फट जाएंगे।
तो
ये काम तो तुमको ही करना पड़ेगा।
पहले खसखस, तू खस खस के मर जाएगा एक दिन। धोबी घाट किधर है? मुझे एक बात बताओ, यहाँ के लोगों ने पिछले 2 साल से कपड़े नहीं धोए क्या?
ए, फालतू बातों में वक्त बर्बाद मत करो। बाकी लोग भी अपने कपड़े ला रहे हैं।
हाँ हाँ, लाने दो लाने दो लाने दो, पूरे घर के कपड़े लाने दो, और पड़ोसियों से भी पूछ लो, उनके कपड़े उनको भी लाने दो। ये सस्ता और अच्छा साबुन है, इसलिए इतनी मजदूरी करवा रहे हो। लहंगा है कि सर्कस का तंबू? ये नौटंकी।
ए नटवर,
एक बात बताओ, इस घर में कितने परिवार रहते हैं?
15-16 परिवार।
हाँ, तो इसको घर क्यों बोलते हैं? इसको जिला घोषित क्यों नहीं कर देते?
काम कर, नहीं तो तुझे रस्सी में सुखा दूंगा। हाँ,
ये कुर्ता किस राक्षस का है?
ये कुर्ता हमारे बड़े साहब का है।
मतलब इन राक्षसों में से और भी एक बड़ा राक्षस है?
ए, नीची आवाज में बात कर। ये लोग तो कुछ भी नहीं है, असली साहब तो वो है मंगल सिंह चौहान। गुजरात गए हैं, आने वाले हैं।
हेलो हेलो, पेटो खाड़ो पुरवा, हेलो। क्या खाड़ो? मैं खाड़ो नहीं खोदूंगा। नहीं, थोड़ी बहुत गुजराती मुझे भी आती है। नहीं जम्मू, नहीं जम्मू, नहीं तो जा भाड़ में। तू जा भाड़ में। ये जा साले, गड्ढा खोद जाके। साले गुजराती समझता नहीं, मेहनत पड़ेगी तब मजा आएगा। यार कपड़े धो धो मेरी हालत खराब हो रही, ऊपर से कह रहा है गड्ढा खोदो। मैं कोई बंधुआ मजदूर हूँ?
अरे पेट में खाड़ो पूर्वा का मतलब मालूम है क्या है? वो खाना खाने के लिए बुला रहा था।
क्या?
जा भी काम कर।
क्या खाना?
हाँ, चौली की सब्जी है, चपाती है और मिठाई में घूघरा है।
खाने में चोली सब्जी और क्या?
चपाती।
चपाती। ओ, मिठाई में क्या था?
वो क्या बोलते हैं गुजराती में? घूंघरा
है?
घाघरा, घूंघरा घूंघरा घूंघरा।
बाप रे, मैं तो कुछ और ही समझ रहा था।
अब कुछ नहीं हो सकता
है?
इस घर का असूल है कि एक बार किसी ने मना कर दिया तो दोबारा उसको खाना नहीं मिलता।
अरे ये भगवान क्या जुल्म है, सारा काम करूं मैं, खाए वो। अब कुछ नहीं हो सकता क्या?
हो सकता है एक बार सबका खाना हो जाए। हाँ। कुछ खाना बचेगा तो मैं उनसे कह दूंगा, वो तुमको बुला लेंगे।
कुछ करो ना, कुछ करो ना।
उठ, जाके कपड़े धो। पैंट गीली कर रहा है मेरी। ये क्या कर रहा है? पागल हो गया क्या?
अचानक मुझे मेरा मालिक याद आ गया, इसलिए होश खो बैठा।
अबे गोंचू, ये तेरा मालिक नहीं है, ये बड़े साहब की इकलौती बहन के कपड़े हैं। जरा से भी फट गए ना तो बड़े साहब तुझे फाड़ डालेंगे। हाँ।
શું કામ છે?
मुझे गुजराती नहीं आती, इसलिए जब उन्होंने खाने के लिए बुलाया तो मैं गया नहीं। मुझे थोड़ा खाना मिल सकता है क्या?
શું?
शू? हाँ हाँ हाँ, शू तो मैंने कब के पॉलिश कर लिए और कपड़े भी धो डाले। अब मुझे क्या वो क्या 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 बोला था उस नौटंकी ने? घाघरो चोली मिल सकता है क्या?
શું? ઘાઘરોની ચોળી?
हाँ हाँ, घाघरो चोली, घाघरो चोली।
કોનો ઘાઘરો ચોળી?
आप दो ना, आप दो ना। आप
અલ્યા લાજ વગરના, તને આ ઘાઘરો ચોળી જોઈએ છે?
જોઈએ છે, જોઈએ છે, જોઈએ છે। अगर आपको एतराज ना हो तो मैं अपने आप ले लेता हूँ। या आप
મામા કાકા જલ્દી આવો, જલ્દી આવો, પપ્પા જલ્દી આવો। અમ્મા મને કહે છે કે તારો ઘાઘરો ચોળી કાઢવો છે।
मांगू छू, मांगू छू, मांगू छू। आप दो ना, आप दो ना।
So now let's continue with ECG events of the heart. So now we will go in a bit more detailed of how each event in an ECG corresponds to various activity in the heart. We know that there are various events such as P wave, PQ segment, Q wave, R wave, etc. etc. What do each of these mean? Initially, when we consider the pattern that's being drawn by a galvanometer, it is one of the voltage patterns by a particular lead. Now, regarding lead, I will be explaining in a detailed lecture in the following upcoming ones. But for now, just let's go with the common or the most famous lead that is used by most ECG teachers for mostly all the videos. And this lead is called lead 2. Now, the pattern that we usually see in lead 2 looks something like this. and this is not one of the best drawings you have seen, but just for now, let's compensate and see what are the different things. A P, Q, R, S, and a T. Now we know what's a P wave. This over here we can see the P wave. Now let's understand what happens in a heart during the P wave, or what event is corresponding the P wave. We know P wave is also called atrial, that is the right and left atrial depolarization. So imagine you have the natural pacemaker of the heart, that is your SA node. Now from the SA node, when the signal of excitation or depolarization has to pass in the form of vector, usually the vector that's present in a if we look in a 2D plane, it's usually from up to down and from right to left, in this way. So usually when we see this in an ECG paper, by the previous rules, if you see if it's a depolarization as or a positive vector and it is moving towards the positive electrode, we should get a positive deflection in the wave, and this is exactly what happens in a PQRST lead drawn by lead 2. We see a positive deflection of dome being formed and coming back to its potential. Next, you can see the PR segment, or sometime the PQ segment. We usually call this the PR segment because in most EKG machine, the Q wave, it's very small in magnitude to be recorded. That's why we call it usually PR segment. But if you want to be logical, it can be also called the PQ segment. So the PR or PQ segment, it is also called atrioventricular or AV node silence. Now, why is it called AV silence and what is its importance? It's called AV silent because conduction over here is very slow. AV conduction is very slow or low. Now, reason for such delayed conduction, one cause is that the number of gap junctions are low. And second common reason, if we remember Ohm's law, the radius of the nerve fiber, it's usually very less. And if the radius is less, the resistance to current flow is high, and hence the current in the circuit is reduced, and that's why the current flow through them is very slow. This slow conduction gives enough time for complete atrial depolarization, and this is also important for maintaining the normal rhythm of the heart. So once AV silence takes place, the conduction does not stop over here, it does not stop, it is just delayed. And next event is that is your Q wave. So this is P wave, this is PR segment over here. Now next is septal depolarization. The QRS complex, it's also called ventricular depolarization, and it is divided into three waves: the Q wave, the R wave, and the S wave. The septal depolarization is the one that denotes Q wave. Now, how is there is a tiny deflection down? To know the direction of it, the vector moves up to, from the bottom to top, and the left bundle branch being thicker is the one that's gonna depolarize the right one. That's why you will see a vector moving up, and when you see the positive depolarization vector is now moving towards the negative electrode, and that's why we see a negative deflection, that is your Q wave. That is your Q wave. Now next It's the biggest or the largest amplitude wave, that is the R wave, and it is in the shortest interval of time. This is because of apical depolarization, because first of all it moves from up to down and from right to left. But since we know when we compare the right atrium with the left atrium is much thicker compared to the right one. It have large number of cardiomyocytes, so higher the number of cardiomyocyte, stronger is the magnitude and stronger will be the vector, and that's why it's a very powerful deflection, and that also towards the left. And that's why you see a very strong R wave that is being recorded in the second. So deflection in an ECG, it depends on the vector, and the vector, it depends on how strong the magnitude is and where the direction of this vector moves. Now going further into the S wave denotes the basal ventricular repolarization. So this is from, the deflection goes through the Purkinje fibers, and as it moves in this direction moves towards the negative electrode, we get a S wave. After the S wave, we have the ST segment. Now the ST segments denotes complete ventricular depolarization, and that's why when we see a complete depolarization as per the rules, we should see an isoelectric line, and that is what's shown over here at this segment. That is, the ST segment denotes complete ventricular depolarization. And after the ST segment, we see the T wave. Now T wave is ventricular repolarization, which begins from the apex towards the base. So a different sign, a different arrow. So when we see a negative vector or a repolarization vector, negative moving towards negative, will give a positive deflection by the galvanometer reading. So this is basically what occurs, or this is the pattern that is being drawn, what is sensed by lead 2 and the pattern which is drawn by the galvanometer on an ECG paper. So first, P wave, it denotes atrial depolarization. The PR segment or the PQ segment denotes AV node silence. The Q wave is septal depolarization. The R wave, the apical depolarization. The S wave, the basal depolarization, and the T wave, which is ventricular repolarization. Now, some of you might ask, if there is ventricular depolarization and ventricular repolarization, where is atrial depolarization? Well, atrial depolarization, it occurs right in the QRS complex, but since the electrical vector that is in QRS or ventricular vectors that are being produced, they are much stronger, that the atrial depolarization is hidden under the QRS complex, and that's why we are not able to see the atrial repolarization on an ECG paper. Now, going further, if you want to know regarding the timing of various event in an ECG paper, or the timing of an and different timing of ECG events.
Hi, I'm Greg.
Hi, I'm Whitney.
Hi, Whitney. How can I help you?
I have a terrible headache.
Oh, I'm sorry to hear that. Oh, I'll get you fixed up. Is there anything else you need? Like bottled water, coffee, mint tea?
No, but that's so nice. Usually the clinic doctors are kind of rushed.
If you can't be nice, why be a doctor? So where do you feel the pain?
in the back of my head here.
Uh-huh. It's Picarius sign. That'll be gone by your third trimester.
I'm not in school.
Neither is your fetus.
Oh, God.
You didn't know you were pregnant?
How do you know that just from the headache?
How do I know? I missed my period. I got fat, threw up. Oh, no, wait, that's how you know.
What?
I know because of the tight shirt stretched over the swollen boobs, the salt craving you imported into the clinic, the motion sickness patch that doesn't do anything for the kind of sickness that you feel in the morning.
I'm a virgin. Says my fiance.
I believe him.
Aren't there other ways I could get pregnant? Like sitting on a toilet seat?
Absolutely. There would need to be a guy sitting between you and the toilet seat, but yes, absolutely. I was doing so well.
Dr. House? This is my fiance, Jeff.
She says you told her you can get pregnant from sitting on a toilet seat.
I said those words, but with particular inflection.
I knew it wasn't true.
Well, is there any other way? Isn't it possible?
There was a reported case of a Civil War soldier who was shot in the testicles, and the musket ball carried the non-musket ball into the uterus of a woman working in a neighboring field. 9 months later, a miracle child was born. Also, maybe she cheated on you.
We made a promise.
We do other stuff in bed. Couldn't some of his sperm have made it up there somehow?
More likely it came from the guy whose penis made it up there somehow, but sure, anything's possible.
I want a paternity test.
Tell him that amnios are dangerous this early on in the pregnancy.
Are they?
Who cares? He doesn't know.
We'll do the paternity test.
Been waiting here for 6 hours. Am I the father or not?
No, but she also didn't cheat on you. Normally, sperm meets egg, DNA meets DNA, goes back to her place, cells divide. 9 months later, joy is bundled. That's normally. Abnormally, an egg could have 2 naturally occurring gene mutations that don't naturally occur together. A spontaneous calcium spike could prep the egg for fertilization without sperm, and a division mistake could let the egg split up without ever needing male DNA at all. Parthenogenesis, a baby without a daddy. In humans, it's only ever been theorized, it was never proved. Until now. Mommy, baby, your daughter has only maternal DNA. I personally checked this 5 times. In 7 months, you will have a virgin birth. Merry Christmas.
We know that when you see an ECG paper, you have a big square. The ECG paper have darkened squares, and each big square will have small 5 squares horizontally and vertically. So there are different speeds of various ECG paper. This is one example in which the speed of the paper or the roll is in 1 minute 300 big squares are covered up. So if we mathematically calculate, if 300 big squares is equal to 60 seconds, then 1 big square will be equal to 0.2 seconds. Also, I as mentioned, 1 big square is equal to 5 small squares. So if we compare this second and first equation, we know that 5 small square is equal to 0.2 second. So in that case, 1 small square is equal to 0.04 second. Now I don't know how well you concentrated all this, but it's better if you memorize this and keep that 1 small square is equal to 0.04 second with specificity of the speed of the paper. Now this is the value of 1 small square in terms of time. Now the value that are can be present for various interval as P wave, PR segment, QRS complex, ST segment or T wave. Now usually the time taken by P wave is 0.1 second. PR segment, the time taken is 0.1 second. For QRS complex, the time taken is 0.1 second. For ST segment, the time taken is 0.1 second. And for T wave, unfortunately, it is just one extra 0.2 second. Now, if you sum it up all, you will get an average of 0.6 second. Now, I know some of you might not agree with this, but this is just a simple classification. There are various books which give a very narrow range, but how to say, of course, all heart don't beat at the same time or at the same rate throughout the lifetime. There will be changes up and down. This is just an average value of, or a hypothetical value of 0.6. Maybe it can be present in some hearts, but mostly it might be no, because such heart, when we calculate, if you want to calculate the heart rate out of it, if one beat is equal to 0.6 second, then in 60 seconds it will be 60 to 1 by 0.6. If you cancel them all out, it will be 100 beats per minute. Now this usually it's not so great, because a value above this you are supposed to have sinus tachycardia, or basically you'll have tachycardia. So this is like the max limit, or the healthy range max limit. Usually the heart rate is 60 to 100. So you can say one way that this hypothetical value is the maximum limit which can be tolerated, and beyond this usually it's pathological. So 100 beats per minute, this is what we are. Of course, you can, if you change these values, you will get a much lower heart rate. Now I like to finish up this topic with lastly talking about QRS complex nomenclature. Now QRS complex nomenclature, you just have to know some rules. When you are naming a QRS complex, there are certain rules which need to be followed. First rule is that a wave above the isoelectric line is called an R wave. Okay, so I'll repeat, a wave that lies above the straight line or the isoelectric line is called an R wave. The initial one we call it R wave, and any secondary R wave we call them R prime, or R secondary, R2 dash and 3 dash, and so on and so on. Then a wave below the isoelectric line are called Q wave and S wave. If a wave is before the R wave, we call it a Q wave, and if it is after the R wave, we call it the S wave. Now there is some ruling regarding capital or small letter. Capital letter is designated to high amplitude waves, and small letter is designated to low amplitude waves. Now keeping these rules in mind, let's try some QRS complex. Now, let's name some QRS complex. Over here the Q wave is small, so it will be a small Q. The R, it's a strong vector, so it will be a capital R, and we have a small s, so it will be a small s wave. Now over here it begins from a deep Q and a small r, so it's a capital Q and small r. Similarly, we can write this initial on top, it is capital R and capital S, and then over here we have capital R, small s, and R prime. Usually over here it's not necessary, always you will see there will be S. Sometimes it can also be above the isoelectric line, as in such like this. So such wave we called it notched R. Notched R wave. And if you find a single wave which is at the bottom, this is called a QS, and a single which is at the top, this is called an R wave. So this is something regarding the nomenclature of QRS complexes.